So the first thing that you really need to start with is knowing what a well-formed formula is. So if everybody knows, the abbreviation for well-formed formula is WFF. So if you see that on the test, that's what he's talking about. He's talking about a well-formed formula. So does anybody know sort of a definition of that, or what are the rules for a well-formed formula?
Has to be valid?
Nope. It doesn't have to be valid. There's actually rules, they were at the very beginning. These are probably things you don't quite think about, but they're really useful to know, sort of in the back of your mind. So these were the ones we actually put like this. So we started with rule 0. And yeah, rule 0 was every, sorry, not every, every elementary formula. Every elementary formula is a well-formed formula. So does anybody remember what an elementary formula is? Like single letters, capital letters. Right, exactly. So yeah, some examples are just A, B, C. P and Q are also elementary formulas. So those are elementary formulas, just single letters there. So the second rule was that given any well-formed formula, a new one can be created. Can be made by adding a tilde. So if you add a tilde to any formula, to any well-formed formula, then that's a new formula right there. So let's say that A is our well-formed formula. If we put a negation in front of it, that's a new one. So the two formulas in negation A are A and negation A. And we can do that for any of them. So say we have negation A dot B. If we put a tilde in front of that, we get a new one. We can keep going. We can make that as long as we want. If we add a tilde in front of the well-formed formula, we get a new one. The second rule then, it's actually the third. I don't know why he numbered it 0, 1, 2. But, so the second rule is given any pair of formulas. So given any pair of well-formed formulas, we can get a new one. We can get a new one by using any of our other operators. So we can use a dot. So a dot, a wedge, a horseshoe, or a biconditional. We can use that to connect any two formulas. So we can have A and B and use a dot to connect that, so that's a new formula there. We have A dot B, and we have C wedge D. We can connect those with horseshoe. We can do that for any number of formulas. So these four operators are used to connect formulas together to create a new formula. And then the third rule is that nothing else. So if it's not well formed, then it's not a formula. Does that make sense for everybody? That's pretty easy, right? Okay. So I guess the question I have for you guys, here's an example. Is that well-formed? No. No. Exactly, yes. We're missing our parentheses, right? So we need parentheses here, or the other way. Is that well-formed? Actually not. On the test, we're going to say that it's not well-formed because we always need a parentheses around the outside. So if you ask if it's a well-formed formula and there's not parentheses around the outside, then it's definitely not. Except for one case with a tilde. There can be a tilde out front and it's still well-formed. Without parentheses. Yeah, there doesn't need to be parentheses around the tilde. That's the only case.
If you did put parentheses around the tilde, would that make it not well-formed?
No, it would still be well-formed.
What if you wanted to add a second tilde on the outside?
That would be fine. Yeah, you can make as many tildes on the outside as you want.
You don't have to use parentheses?
Right. Yeah. Yep. Yeah. The only case would be is if you had a tilde here, you can't just get rid of parentheses. So if we have a tilde there, we would still need the parentheses because that's connected to the A and not to the entire thing.